Hey guys, in this video I'm going to show you how to process your data for the Motion and Graphical Analysis Lab. This video is for how to do the processing on Google Docs. If, however, you wanted to use Microsoft Excel, there's a different video for that. If you are attempting to use your iPad, there is a different video for that. The desktop computer is probably the ideal way to do it, however, so if this is what you want to do and you've got a desktop computer at your disposal, keep watching. So to begin with, the data has been sent to you from from Pasco equipment, and it should come to you as a .csv file. So here you can see there's a bunch of different .csv files. I'm going to just open this one by way of demonstration. This is what it looks like, but I can't edit this yet because it's not actually a Google Sheet yet. So to fix that problem, I click Open With, and then I'll go down to Google Sheets. All right, now I'm not going to do that. I already made a separate set of data here called Demo Exported Data. But as you can see, when you do it, it creates a duplicate of it, which is a Google Sheet. That's not really a problem. Here we go. All right, so this is my exported data that I'm going to do the demonstration on. Now, before I start just doing stuff, let's look at a little overview of what am I trying to accomplish here. So there's 5 different steps in processing my data. I want to delete all of the extra columns. I want to make a scatter plot. I want to delete any crap data points. And then I'm going to make a trend line. And we also got to talk about how to format the title and axes. All right, let's begin with deleting the extra columns. Extra columns would be things like date and time and acceleration. Don't need those things for this particular experiment. Really, the only ones you need are the ones that say time, position, and velocity. Now, the way this data is formatted, you can see it's got run 1 is all these columns, run 2 is all these columns, and run 3 is all of these columns. So if your data has been sent to you like this from the Pasco sensor, that's normal. That means all 3 of your runs are in there together, and you got to make sure you remember which one is which. All right, now, run 1 for me was constant velocity. I do not need this column, so what I'm doing with my computer is I'm doing Control and then click on it to bring up these options. And I want to delete the column entirely. It's gone now. All right, same thing for, we said we don't need the acceleration data. We're not going to graph that. All right, and then I can go through and do it for all the various runs if I want to. I'm only going to really show you processing run 1, but this is what you would need to do for all of them. All right, let's go through, delete those stupid extra columns that we aren't going to graph. All right, how we doing? Create a scatter plot. That is the next step. Now, in Excel, a graph is called a chart. Or excuse me, Google Docs, it's called a chart. And so what I will do is I will highlight, say, these 2 sections of data. All right, now, if you're not sure how I do that, I click on the label up here at the top where it says A, and that will highlight that entire column. I can also highlight an entire row if I want to by doing that, but I'm going to stick with I want an entire column. And then I want an entire another column, because I'm not just going to graph time versus nothing, it's time versus position. So I have to select both columns. In order to do that, hold down the Shift key and then click. Next, we're going to insert a chart. Now, that is technically a graph of something, but this is the stupidest graph in the world. This is called a line chart. And depending on what the last thing is that you graphed or whatever, I'm not sure how it picks the defaults, you might get something wonky like this. This is the wrong kind of graph. We want something else. We want something called a scatter plot. Now, frustratingly, this looks exactly the same. So it turns out there's another couple of things that you've got to uncheck down here. First thing is, I'm really not sure what that one even does. Yeah, I don't care about that. All right, and then this one, use column A as labels. I don't know why that's the magic word, but that's what it is. You check that one, and now we have a graph of position on the vertical axis and time on the horizontal axis. Now, if after doing that, yours still doesn't look like mine, the problem could be somewhere over here. Okay, so I'm going to scroll up and down in this a few times. You make sure that yours looks just the same as mine. And if it doesn't look exactly the same, then that would be the source of the problem and the reason why it doesn't look like a good graph. All right, let's see how we're doing. I have created a scatter plot. Success. Step 3 is delete all of the crap. Now, pre-motion data points, that would be these ones right here. That's before the cart was even moving. It's just sitting in front of the motion sensor. Then I push it, and it's rolling along. And then this right here is when it hits the bumper. That's also a crap set of data points. So really I should say pre and post motion data points. And I need to delete those. It's really important that you delete all of the same data points for all three columns, all three remaining columns, for a particular run. The reason is that when you do your calculations, you need position and velocity to be graphed over the exact same time interval. Okay, so I'm not going to just be like, hey, I'm going to delete that. No, don't do it that way, right? Highlight, like this, all of the things that you're going to delete. All right, how do I know what I'm going to delete? Well, I mean, you could just start deleting and see what happens, because you can always undo. But sort of zooming in right here, I can see somewhere between 0.5 and 1 is my first, like, real data point. So that looks to me like it happens at about, 0.8. So let's get rid of that one. Maybe we'll go a little further. Okay, that looks like, that looks pretty good, right? This right here, those dots seem to be forming a straight line, which is good because run 1 was constant velocity. If this were run 2, which for me is positive acceleration, then I wouldn't be expecting a straight line. But for this run, that's what I should see. All right, now we got to also do the same thing for the crap data points at the end. That looks like it's happening at about, 2.4, maybe 2.45, something like that. If you're having trouble zooming in on exactly which data points, you can also look at the values here and what they seem to be doing. My position data seems to be going up, 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 right? Increasing by about 0.02 or 0.03. Oh, look at that. Suddenly, it's not increasing and it's moving backwards. I can also look at my velocity data and see if it's following the right trend. And here I can see it kind of stopped following that same trend of being, roughly speaking, constant, which is what I want for this run. If it were a different run, it would be a different trend I'd be looking for. All right, so we'll delete all those. Let's go back up, and there's my pretty nice looking graph now. I'm pretty happy with that. Okay, now before we go on to the next step, so that this thing isn't like cluttering up my space in here, and if I wanted to then go back and do runs 2 and 3 and it's all in the way and everything, I'm gonna click these 3 dots and move the chart to its own sheet. And there it is down there. It's its own sheet now all by itself. All right, and that way it's not cluttering things up when I want to, go back and do my other runs. Okay, the next thing. Oh, noise. I didn't mention noise because in this particular graph there wasn't any noise, but noise would be something like, let me go jack up my data here. How about this says that instead? No, look, that point's way out of place, right? Now, noise happens when the motion sensor finds something else that's not the cart, like if you put your hand in the way or something like that. So if you've got a noise data point, what you'll need to do is delete it, like this. There. I deleted the noise, which granted I just fudged the data and made up that noise. But if your data really actually has noise for some reason, then you will need to delete that noise, because otherwise it's going to mess up the rest of the stuff that you're going to do. Step 4, we're going to make a trend line. Now, for making a trend line, we're going to need to click on Edit Chart. And then this menu comes back up that I was looking at earlier. All this stuff is good. Where we need to go now is to Customize. And so there's a lot of different things you can do in here. In order to add the trend line, you go to Series. So see under Series, if I go down here, it says Trend Line. Huh, there it is. Click it. Okay, and now for the trend line, I mean, you can see, look, it added a line. And it fits the data pretty good. But I need a little more. I need an equation. Okay, so now it's actually showing the equation of the line. And then the last thing is I'm going to go ahead and check Show R squared. What R squared is a measure of the statistical fitness of your linear regression. If that all sounded like a bunch of nonsense, all it's really saying is if R is 1, then your line is a line, meaning the data fits a linear graph. If, I had like a big curved graph, right, instead of this nice straight one, right, I'd been like, whoa, curved, then a linear regression, a trend line, wouldn't have fit the data, and therefore my R squared value would be less than 1. Okay, so the value of 1 means I did great, all right? It fits it really well. If, on the other hand, you had not done these other points that I mentioned of, deleting the crap data points, your trend line would look like this. Follow what I'm doing with my mouse. It would not have fit the line, and your R squared value would have been garbage, and your slope would have been meaningless. All right, so let's see. Well, great, we're doing awesome. We've got our linear graph with a trend line on it, and our equation and R squared values are on there. So the last thing is we need to format the title and the axes. This title here is like okay, but we could probably do better. With the title, you can click on it and edit it right there, or under Customize, we can go to Chart and Axis Titles, and then I can type in whatever I want. For this one, don't call it Run 1. Don't use Run 1, Run 2. I don't know what order you necessarily did things in. Call it by a name that is actually like defining what you did. So this is the constant velocity. We could also have said 0 acceleration. Constant velocity, and this happens to be the position versus time graph. All right, looks solid to me. I like it. Now, the next thing is we need to add axes. Our axes need titles as well. If you don't label your axes, well, no one knows what you graphed. I mean, it set it up here, but I don't know if this is time or that's position or what. And so the way that you edit the axis titles is still in the same part here. We click on where it says Chart Title. It's a drop-down menu. Chart Subtitle. Ooh, I could add a chart subtitle? That sounds like fun. Awesome. So no, we don't need a subtitle under it, but you could add one for fun. Horizontal axis title. Now let's see. I want it to be horizontal axis is time. Don't forget to say seconds. You need units on your axes because it could be time in minutes, I suppose. Vertical axis title. The vertical axis for this particular graph is position, and that's measured in meters. And now I have a beautiful graph. It's just exactly the sort of thing that I want. At this point, you are done with this graph, and you can go on and make some more. If you want to get this graph into, say, a document of some kind, whether it be Notability or a Word document or Google Docs, you go to Download Chart, maybe Publish Chart. I'm not sure what that does, but Download Chart, and you can get it as a PNG or a PDF, or I suppose a vector image if you want. But either of these is probably a good option. If you're just submitting the document directly, PDF. If you're trying to put it in something, a PNG is probably easiest for that. All right, that covers everything. I hope that was helpful. Thanks, guys.